radiations. So this was the last week mock exam related to block 3, which is about the waves. The first question is, which is the unit of a wavelength? So from length, what is the unit of the length? The unit of the length is meter. So hertz, what is the unit, which quantity we can measure in hertz? That is the frequency. Meter, that is the wavelength or a length of a wave. Meter per second is a speed, and second is a time. So which is the unit of the wavelength? The unit of the wavelength is meter. So B is the right answer for this.
Oh,
In question 2, which diagram correctly shows a ray of a light reflected by a plane mirror? Whenever a reflection occurs, the angle of incidence is always equal to angle of reflection. So why A cannot be an answer? Because when you check option A, the angle of incidence is 40, but angle of reflection is given 50. So that's why A cannot be an answer. What about B? The angle between the surface and the incident is 50. So what will be the angle of the incidence? The angle of incidence is angle between the normal and the incident. So if the angle of incidence is 40, the angle of reflection should also be 40. That's why B cannot be a right answer. Same way C, if the angle of incidence is 40, angle of reflection should also be 40. But according to this calculation, if this angle is 40, the remaining angle between the reflected and the normal, which is angle of reflection, so that should be 50. So in this figure, the angle of incidence and angle of reflection are not same. When you check option D, the angle between the surface and the incident is 50. So the angle between the normal and the incident, that is 90 minus 50, so which is equals to 40. So angle of incidence is 40 and angle of reflection is also 40. Whenever a reflection occurs from the plane mirror or any surface, the light will always follow a law of reflection which states that angle of the incidence should equal to or must be equal to angle of reflection. In question 3, which diagram shows a converging lens used as a magnifying glass? Whenever a convex lens or a converging lens is used as a magnifying glass, what should be the position of object? The object is always placed between the focus and the lens. So when object is placed between the focus and the lens, the image form is always a magnified and a virtual image. So just you will check the position of object to identify what could be the likely answer. So first, when you check, A cannot be an answer. Why A cannot be an answer? Because the object is after focus. So A cannot be. For B, B can be an answer because object is between the focus and lens. C can be an answer, or D can be an answer as well. But to form a magnified image, the term magnified means the object, the image size should be larger. And image is also formed on the same side as the object. So when you check option C, the object is on the left hand side and the image is on the right hand side. That's why C cannot be an answer as well. When you check option D, so how the image is formed by a convex lens as a magnifying glass. So first a parallel light ray. The parallel light ray from the object will pass through the focus, and one which is through the optical center. So this is the object. First the parallel light ray till the lens will pass through the focus, and one through the optical center or the center of the lens will pass straight. So when we see, when our brain sense the light is coming straight from the object, so it produces the two light rays backward, and this is a position where the image will form. So B will be the right answer. Why A is incorrect? A diagram is correct, but in the question, as you can see, as a magnifying glass. So image formed by a convex lens as a magnifying glass is always a virtual image. So the nature of the image should be virtual. So here the figure is correct, the diagram is correct, but what it represents, that this is a real image. And how it is a real image? First, the light ray passes, parallel light ray passes through the focus, one through the optical center will pass straight. So the two light rays will meet at one point. So this image, what is the characteristic of this image? This is a real image. It is inverted.
And Mr. also because he made it connected line, not dashed line.
Yeah, the same idea, because the magnifying glass, whenever a convex lens is used as a magnifying glass, the image is always on the same side and it is a virtual image. Virtual image means it's not real, it is imaginary, we cannot see or take on the screen. But here what happened, this is a real inverted and a magnified image. So this image can be seen on the screen, but as a magnifying glass, what are the characteristics? It should be virtual, it should be upright, and it should be magnified. So even though it is a magnified, this is also a magnified image, but it is real and inverted, but magnifying glass produces a virtual, upright, and magnified image. Is it clear that why B is the right answer for this?
Yes, Mr. Clear.
The next question, a sound wave travel from point X to point Y. So if the wave is traveling from point X to point Y, what is the direction? Because sound waves are longitudinal. In a longitudinal wave, the particle vibrate parallel to direction of the wave. So if the wave is traveling from X to Y, how the direction of the particle will occur? That is between X and Y, the particles will vibrate. That's why D is the right answer. If the same question was there, and instead of sound wave, they ask, you have water waves. Like instead of sound, if we have the water waves, so water waves are moving along point X and Y, then what should be the right answer? Because water waves are transverse, so the direction of the particle is perpendicular to direction of wave, like up and down. So in that case, C will be the answer. But because the question is a sound wave, in a sound wave, the particle vibrate parallel to direction of the wave. That's why D is the right answer. In question 5, the speed of a sound in air is 340. Which wrote typical values of speed of sound in liquid? In liquid is about 1500 and in solid is about 5000 meter per second. You have to learn these values so it matches with option D. Sound travel faster in solid compared to that in liquid, because in solid the particles are tightly packed together. So sound required a medium to travel from one place to another. In a shallow tank, water waves moves towards a barrier of a narrow gap. Narrow gap means when a gap size is smaller than the wavelength. Like this is the wavelength and this one is a gap size. Gap size is smaller than the wavelength, narrow gap. And whenever you have a narrow gap, you will have a maximum diffraction. Maximum diffraction means the wave will spread out more. So which diagram represent the maximum spreading of the wave? So that is represented by D. That's why D is a correct answer for this. If it was a wider gap, then a small diffraction will occur, then B will be the right answer. But because it's a narrow gap means maximum diffraction, wave will spread out more. That's why D is the right answer. A light passes along an optical fiber or fiber optic or light pipe. Example, for communication or endoscopy, we are using an optical fiber or fiber optic. What happened to a light? So this is a transparent medium. When the light is strike, this angle here, when the light strikes, this angle is more than the critical angle. This angle of incidence is more than the critical angle. So what will happen? The light will undergo total internal reflection.
Reflection.
Yeah. So that is total internal reflection when the light passes through the optical fiber or fiber optic and reaches the other side. So It is not diffraction. Diffraction means when the white light, when there is a white light, when it passes from one medium to another, it spread out into 7 colors: violet, indigo, blue, green, yellow, orange, and red. This spreading of a light is known as diffraction. Means spreading of the wave around an obstacle, like when the wave is passing through the gap, it spread out, we call diffraction. Dispersion means when the white light spread into 7 color: violet, indigo, blue, green, yellow, orange, and red, we call that as dispersion. Refraction means when the light travels from one medium to another, it changes the speed, we call refraction. And total internal reflection, when the light bounces back in the same medium. So D is the right answer, because the light, when strike the medium, it bounces back and undergo total internal reflection. Points label F are the principal focus of a lens. A beam of a parallel light is incident. Which diagram shows a path of a light after it passes through? Look, whenever we have a parallel light ray, it should always pass through focus. So A cannot be an answer. Why? Because it is not passing through the focus. Here, parallel light ray, when it passes through a converging light, it always converges at a focus. So B is the right answer. C, again, it is wrong, because it is not passing along through the focus. And D is totally wrong. It shows the light is reflected back, and it is passing along the focus, but it is reflected back. But in a lens is a refracting surface. It allows the light to move from one place to, like, from it enter from one side and leave from the other. That's why D is also wrong, because it should pass through the other side focus, not the same side focus. So whenever light rays are passing through a converging lens or a convex lens, there are 3 ways the light rays can pass. Number 1, if it is parallel light ray, it will pass through focus. Number 2, if it is passing through the center, it will pass straight. Number 3, if it is passing through the focus, it will go parallel. So these are the 3 ways the light can pass through a convex lens. Which statement about the sound wave is correct? They are able to travel through vacuum. Sound required a medium to travel. Sound cannot travel through vacuum. They are able to travel through solid. That is true. Sound can pass through or travel through solid, liquid, and gas. They are transverse. Sound waves are not transverse. Sound waves are longitudinal, in which the particles vibrate parallel. And they travel at the same speed in all substances. That is totally wrong, because sound travels faster in solid compared to that in liquid, and liquid it travels faster than gas. Approximate speed of a sound in solid is about 5,000, in liquid 1,500 meter per second, and in gases about 330 meter per second. So it does not travel with the same speed in all medium. It travels faster in solid compared to that in liquid, and liquid it is more than gas. So B is the right answer, that sound can travel or sound can pass through solid. In question 10, which statement about the ultrasound? The audible range for a normal human ear, that is from 20 hertz to 20,000 hertz or 20 kilohertz. So a sound, this is the audible range. Audible range means this is the sound which we can detect. So any sound more than 20,000 is called an ultrasound. And this ultrasound our ear cannot detect. So ultrasound means a sound with a high frequency. And how a sound with a high frequency can be produced? It can be produced by an object which is vibrating very fast. It is uncomfortable to human ear. That is wrong. Why this is wrong? Because the sound wave, our ear is not able to detect these sound waves which are having a frequency more than 20,000. So we are not able to detect them at all. A loud sound, a sound which is having a high loudness or intensity, that will be uncomfortable, not the ultrasound, because our ear cannot detect this ultrasound, so we don't detect anything. That's why it is not uncomfortable to human ear. then its frequency must be greater than 300 kilohertz, not 300 kilohertz. Its frequency must be greater than 20 kilohertz or 20,000 hertz. So any sound which is having a frequency more than 20,000 hertz is known as the ultrasound. And it travels faster in vacuum. Sound, any kind of sound cannot travel through vacuum. So this statement is totally wrong. So the correct answer, it is produced by a rapid vibrating source or object which is vibrating very fast will produce an ultrasound. Which shows an example of a transverse and a longitudinal wave. Transverse wave means in which the particles vibrate perpendicular, and longitudinal means in which the particles vibrate parallel to direction of the wave. The only longitudinal wave which you are studying about the sound waves and wave in a string. And the transverse wave, all electromagnetic radiation such as radio waves, microwaves, infrared, visible, ultraviolet, X-rays and gamma, all these radiations are transverse. So which is a transverse? Light waves or visible light, they all are transverse, and sound waves are longitudinal. So B should be the right answer. An object is placed before a plane mirror as shown. A student views an image of an object from point P. Where does he see? Remember, for a plane mirror, the object distance from the mirror is always equal to image distance, the perpendicular. So when you measure this distance, the object distance and the image distance should be equal. So which distance? If object is placed, like example, 2 centimeters from the mirror, the image should also be 2 centimeters. So which point it matches with? It matches with point D. So image formed by a plane mirror are always same in size and same distance from the object as the image distance. So they have the same distances. That's why simple way to solve this question, you will measure the distance between the object and the mirror, and then measure a distance between the object and the image. Both distances should be equal. So that's why D is the correct answer. If object example 2 centimeters away, the image is also 2 centimeters away. And both are in the same line. Light has a speed of 1.24 exponent 8 meter per second in diameter. What is the refractive index? Formula to get the refractive index and in terms of speed, that is speed of light in air divided by speed of light in medium. So n is equals to 3 into 10 to the power 8 divided by 1.24 into 10 to the power 8. So when this will cancel with this, so it is actually 3 divided by 1.24. So when 3 is divided by 1.24, this will give us 2.42. So C will be the right answer. Which statement describe a monochromatic light? Mono means one, chrome means color. So monochromatic, what is the correct definition for a monochromatic light? Light which is having only one wavelength, or the light which is having only one frequency. A light with a single frequency or a single wavelength is known as a monochromatic. Light that does not diffract, that is wrong. All kind of light will diffract. So diffraction is there, a characteristic of a wave. Light which is having a single frequency, only one frequency is there, we call that as a monochromatic light. The light that spread out when shown onto a glass prism, a monochromatic light does not spread out. A white light can spread out. Like if you have a prism and there is a white light which is a combination of 7 colors including violet, indigo, blue, green, yellow, orange and red. So when the white light shown onto a glass prism, violet bends the most and red bends the least. So white light can spread out, monochromatic light cannot spread out. So why the light that spread out, that is wrong. because monochromatic light cannot spread out. It is only one color. It just refract rather than spread out. Light travel at the same speed in all material. That is again wrong, because light, any kind of light is there, it travels faster in vacuum, followed by air, and in air it travels faster than solid, liquid, and in liquid it travels faster than solids. So the answer B option is correct, that the light which is having a single frequency or the single wavelength. In question 15, both amplitude and frequency of a sound decreases. What happened to a sound? So amplitude of a sound affects the loudness, and the frequency of a sound affects the pitch. If both of them decrease, so loudness will decrease, the pitch will also decrease. So if the loudness will decrease, the sound will be quieter, and if the pitch is decreased, it will have a lower pitch. That's why option D is the correct answer. A sound wave is traveling through water. What is the possible speed of a sound wave? So speed of a sound wave, this can be in gas, this can be in gas, this one is in liquid, and this one is in solid. So C is the right answer, that 1500 or 1500 meter per second is a possible speed of a sound in liquid. The structure question, figure 6.1 represent a waveform of a sound. The wave is traveling at a constant speed. The displacement and different arrows are given on a figure 6.1 label with a letter X to mark a corresponding distance amplitude. Amplitude is actually like for a transverse wave. What is the amplitude? The amplitude is a distance from mean position to extreme. So either the vertical upward displacement or a negative displacement from the mean position is amplitude. So which arrow is representing an amplitude? So the first arrow X is represented by amplitude. Not this one, this is double of amplitude, because you can see it is up and down both. So this arrow is not representing amplitude. This is representing twice of amplitude. Then label with letter Y the corresponding wavelength. Wavelength is the length of a one complete wave or distance between the two successive crests or trough. So you can label this as Y because this is one complete wave that is representing a wavelength, or the distance from one crest to another. So this is one crest, this is another crest. So distance between the two successive crests, that is also wavelength, represented by letter Y. And this is just a half of wavelength. So this is Y by 2 or half of wavelength. So you have to label only with letter X and Y, the wavelength as well as the amplitude. The next part, state what happened to the amplitude and the wavelength of a wave if a loudness of a sound is increased at a constant pitch. Pitch refers to the frequency, and loudness increased. So loudness is refers to amplitude. So what will happen to loudness is increased, so amplitude will increase. And constant pitch means pitch is not changing. Remember, what is the relation between the frequency and the wavelength? If speed is constant, frequency and wavelength are inversely proportional. But here, because we are not changing the frequency, so the wavelength will not change as well. So it will be constant. The pitch of a sound is increased. Pitch refers to frequency. So if we increase the frequency, what will happen to the wavelength? The wavelength will decrease. So there will be a decrease in the wavelength because the pitch shows the frequency of a wave. If the pitch is increased, it means the frequency is increased, and when the frequency increases, the wavelength will decrease. What about amplitude? Because it is a constant loudness, the loudness is not changing. That's why the amplitude will remain unchanged or constant. So it is increase constant for the first one and constant decrease for the second one. A ship uses a pulse of a sound to measure the depth of sea beneath the ship. Like example, this is the water level. So a ship is sending an ultrasound which strike and bounce back. So what is the total distance traveled? So that is equals to 2d, because going and coming back. So whenever there's an aqua reflection, the formula speed is 2d divided by t. So if you need distance, it will be speed multiplied by time divided by 2. The speed of the wave is 1500. The time, this is 54 milliseconds. Some of the students did not convert this time. They just directly write 54. It is 54 milliseconds. So we have to convert it to second. You can divide by 1000 to convert millisecond into second. So it is 0.054. So the time is 0.054 and divided by 2. So this will give us 40.5 meter. Yes, you can use the term longer or a shorter amplitude. You can use those terms as well. It does not, it's the same thing, same concept. So 40.5 meter is the distance between the ship and the seabed. Then the definition explain what is meant by the term total internal reflection. So what is the definition of total internal reflection? When light bounces back in the same dense medium, we call that as a total internal reflection. And what is the critical angle? The angle of incidence is known as critical angle when the angle of reflection is when angle of refraction is 90 degrees. So the angle of incidence is known as the critical angle when the angle of refraction is 90. So we call that as a total internal reflection. Next part, figure 7.1 shows a ray of a light traveling in air, incident on a glass prism. We have to calculate a refractive index. So what is the refractive index? Whenever speeds are given, so the formula for refractive index of speed of light in air divided by speed of a light in medium. So this formula is independent. Light can travel from air to glass or glass to air. So when we solve, it is 1.5. And remember the refractive index. Remember the refractive index does not have any unit. Then shows that the critical angle is 42. So what is the formula? The formula which relates the critical angle and refractive index, that is the refractive index is 1 over sine c, 1 over critical angle. This is a formula which relates the critical angle with the refractive index. So the refractive index we already calculated, it is 1.5. So 1.5, or you can also say that sine c is equals to 1 over n. So sine c is equals to 1 divided by 1.5. So 1 divided by 1.5 is 0.66. So sine c is equals to 0.7 0.66, a recurring decimal. So if you need the critical angle, that is sine inverse 0.66. So sine inverse 0.66, that is about 41.6 degrees. That is the critical angle. Then on a figure 7.1, draw carefully without calculation the continuation of a ray through the prism and into the air. And it's of 3 marks. We know the critical angle is about 42. So first, when the light is moving, it is passing along the normal, so this light will pass straight. So light is moving along the normal, this light will pass straight. Then what we do, we draw the normal here and we'll check what could be the angle of the incident at this point. Because if this angle, the angle here at this point, the angle of incidence, if it is less than the critical angle, there will be a refraction, simple refraction. But if it is or less than or equal to critical angle, there will be a simple refraction. But angle of incidence is more than critical angle, then there will be a total internal reflection. So when you check this angle, this is 60, this one is 90, so remaining this will be 30. And remaining this is 30, the angle of incidence will be 60. So if the angle of incidence is 60 and we calculated the critical angle for this glass is about 42, so angle of incidence is more than the critical angle, what will happen? The light will undergo total internal reflection, or this light will bounce back with an angle of 60. And when we draw the normal here, as you can clearly see, this is obvious that this angle will be less than 42. So what will happen? The light will undergo a simple refraction, or when moving from glass to air, it will bend away from the normal. So this is a path which we have to draw to show how the ray of a light is passing when it hit or passing along, first entering the glass, and then to first part is total reflection and the second part is a simple refraction. Question 19, two students are asked to determine the speed of a sound in air in a school playing field. This is the operator. So what we need because we want to measure a distance. So we need a measuring tape or tape measure and or paddle wheel and a stopwatch. List the readings that student need to take. So student should measure the distance and the time. And how speed of a sound can be calculated from this reading? So speed of a sound is actually equal to distance traveled by the sound divided by time taken. State one precaution they should take for improved accuracy. So should repeat the experiment. And the table gives some speed. What is the approximate speed? The order in air is about 300, so it is closer to 100, and speed of sound in water 1500, so it is closer to 1000. Question 20, you have a plane mirror. So two rays are there at point O. These rays are incident on the plane mirror. What we have to do on a figure, continue the path of a two rays, hence locate the image of this object. So what happened? The light rays will bounce back. So how to locate the image? So when we produce these two light rays backward, this is how the image is formed by a plane mirror, and it is also virtual. The first two light rays from the object strike the mirror and bounce back. When we observe, our brain sense light is coming straight from the object and locate the position of image. How to draw simple image by the plane mirror? So what you will do, the first thing, you will measure the distance between the object and the mirror and draw the same distance. Like example, using a ruler or scale, you measure this distance, say this is 2 centimeter. So what you will do, you will measure the same 2 centimeter from the mirror to the position of image. So you will draw the image first without drawing any lines. And now what you will do, after drawing the image position of image first, you just draw an arrow and join them on the mirror. Draw 2 arrows from the image and join them on the mirror so that you will get the correct position of the image as well. And here we will have an eye. So instead of like common mistake what student used to make, they try to complete these two rays first and then they try to locate the position of image. And when you try to locate, if a small difference in the angle is there, you will not get the correct position. So the simple way to do the image formed by a plane mirror, you'll measure the distance between object and a mirror and then measure the opposite distance for image, the same distance, and draw the two rays from the image on the mirror. So this is a simple way to get or identify the position of image and describe a nature of this image. So this image is virtual image or laterally inverted. Why virtual image? Because this is just our imagination. It is not actually can be taken on seen on the screen.